today's class on mole concepts. So today we're looking at mole concepts, and of course you know that mole is one of the fundamental quantities. Okay, it measures the amount of a substance. So mathematically, we say that mole is given by mass divided by what? Molar mass. Remember that the unit of mass is in grams, while the unit of molar mass is in gram per mole. Okay, so from this you can see that the SI unit of mole is also given as mole. Okay, so mole is given as the mass of a substance all over the molar mass. So this is equation 1. Take note of this equation, very important. So now, given that mole is mass over molar mass, we can interchange these things to get either the mass or the molar mass depending on the question. So we can have here that mass also is given as mole times molar mass. So you can evaluate any quantity at any given time. Take note, you can evaluate any quantity at any given time. You can evaluate the mole. If you know the mole of a substance and you know the compound or the molar mass of that compound, you can get the mass. If you know the mass of a compound and you know the molar mass, you can evaluate the mole. So this is the first formula you have to know in mole concept. It's very, very important because you can apply most of these formulas when you get to topics like stoichiometry and the rest of them. We can relate this mole to Avogadro's number. A man called Avogadro did an experiment and was able to conclude that 1 mole of a given substance is equal to a constant, which we call the Avogadro's constant. So this Avogadro's constant, which is Na, is given as this value, 6.02 times 10 to the power of 23. So what it means is that in 1 mole of any substance, the number of atoms or particles present in 1 mole of a substance is equal to this Avogadro's constant. So with this, we can evaluate the number of moles in a particle or the number of particles present in a given mole. So from here, we can have that mole is equal to number of atoms all over the Avogadro's constant, which is 6.02 times 10 to the power of 23. So with this, we can also evaluate either the mole or the number of atoms present in a given mole. Recall that mole, from our first formula I gave you, that the mole is also mass over molar mass. So if I have this, remember that this also is equal to mass over molar mass. So we can substitute that into this place so that we can have that mass over molar mass is equal to number of atoms or particles all over 6.02 times 10 to the power of 23. Now, look at the question on the board. We are told to calculate the number of moles, how many moles of this nitrogen atom are contained in 6.15 grams of nitrogen. This is a simple question, okay? So, recall what we said, that mole is given as mass, the given mass over the molar mass of that atom. So mathematically, mole is equal to mass over the molar mass of the atom or the molecule or the compound as given in the question. So now, since we are looking at nitrogen atom, remember, nitrogen atom is just N. But nitrogen molecule is what? N2. So you have to be very careful. This is for atom, this is for molecule. So the question is regarding the atom and not the molecule. So we're going to make use of the molar mass of the atom. Of course, you should know that nitrogen, the atomic mass is 14 grams per mole. Okay? But for this is not 14. If the question has said molecule, we would have used 28 gram per mole. What did we do? We simply multiplied the atomic mass by the number of atoms, okay, which is 28. So take note, we are not going to use 28 to solve this question because the question is saying for nitrogen atom, which is just one nitrogen. So from the question is very simple. The mole is equal to, our mass from the question is 6.15 grams all over the molar mass or the atomic mass of this, which is equal to 14 gram per mole. So you should know that gram can cancel gram. So we are going to have 0.439 moles. Okay? You can confirm this with your calculator. You can divide this and you get this. So this is the number of moles present in this given mass of nitrogen atom. Now, take a look at this, another example on mole concept. Okay? So for this, we are asked how many moles of atom of aluminium are present in 9.47 grams of aluminium. Look at the question. How many atoms of aluminium are present in 9.47 grams of aluminium? Recall what I told you. First of all, we know that what was given in this question was the mass. Okay? What was given in this question is mass of the aluminium. Okay? And the element is aluminium. So, of course, the atomic mass or the molar mass of aluminium is 27, right? Gram per mole. So we have the molar mass. Okay? Now, we are looking for the number of atoms. From our Avogadro's law, we know that 1 mole of an atom contains a constant number of atoms, which is the 6.02 times 10 to the power of 23. So from that expression, we were able to derive a formula which I gave you in the previous class, that mole is equal to number of atoms all over the Avogadro's number, which is a constant number, 6.02 times 10 to the power of 23. Now, recall that this mole, from our previous class, we know that mole is equal to mass over molar mass. Now watch the equation on the board. Look at this equation. Look at this. This was not given in the question, but we were told that this mole is this over this. The mass was given. Look at it here. The molar mass of aluminium is 27. So we can actually substitute this inside this. We can actually say that this is also equal to mass over molar mass. So that we can now equate this and solve for the one we are looking for. We are looking for number of atoms. So quickly, if I make this number of atoms subject of formula, what will it look like? If I make number of atoms subjects, so it's going to be number of atoms equal to, from there, you have the number of atoms becomes molar mass times the Avogadro's constant all over molar mass. So from here now, we can solve for the what? For the number of atoms. So the mass was given as 9.47 times 6.02 times 10 to the power of 23 all over 27. Right? Yes. So quickly, the final answer is 2.11 times 10 to the power of 23 atoms. So this is the number of atoms that is present in 9.47 grams of aluminium.